Hi everyone, Assalamualaikum and welcome. I'm Rahimawati from Politeknik Syed Nasir Syed Ismail. Today I would like to share about our research on gluten-free dumpling skin made with sweet potato and tapioca flour ratio. This study explored the development of gluten-free dumpling skin using sweet potato and tapioca flour, focusing on their physicochemical and sensory properties to meet growing consumer demands. Let's see what in my slide we have introduction, objective, literature review, methodology, the results, and the conclusion. More people now can't eat gluten due to health reasons or healthy lifestyle. We know traditional dumpling skin use wheat flour which is not suitable. We use sweet potato and tapioca because the sweet potato offers dietary fiber and vitamins, while tapioca flour provides neutral flavor and binding properties. Our study had three main goals. First, develop dumpling skins using different sweet potato and tapioca flour ratios. Second, to test their texture, composition, and sensory acceptance. And third, to find the best balance based on lab data and what people actually like. Okay, let's see the literature review. Why we use sweet potato flour? According to Zhang et al. 2022, sweet potato flour adds fiber, antioxidant, and protein. It keeps dumplings moist and naturally sweeter. Okay, why we use tapioca? Tapioca flour have their own properties. Because of high amylopectin, it contributes to excellent binding. It also provides neutral flavor to the product. Due to the high amylopectin, gelatinization also high, so it creates soft, which means chewiness and elastic texture. But too much can make them rubbery or blunt. Therefore, we focus on balancing starch and protein to get the right texture for our dumpling skin. How about starch-protein interaction? The texture of gluten-free foods is largely shaped by starch and protein interaction. Starch gelatinization gives structure and chewiness, while protein adds elasticity and firmness. So, a balanced ratio is key to desirable dumpling texture. This is research methodology. We prepare the formulation and then do analysis, which is proximate analysis, texture analysis, and sensory evaluation. For material and methods, the material primary ingredients for those which are sweet potato and tapioca flour were sourced commercially. Then additional dough components such as water and salt were used. Three dough formulation mix which formulation 1 we use sweet potato flour 30% and tapioca flour 70%. For F2, sweet potato flour and tapioca flour is balanced, which is 50%. And formulation 3, we use sweet potato, tapioca, sweet potato 10% and tapioca 19%. The dough formulation will mix and then kneading and resting process at room temperature. Dough was rolled, cut into circular skin, then steam for 10 minutes at 100 degrees Celsius. And then the product is cooled and stored in a tight container to further analysis. And then we do approximate analysis. So this research focuses on moisture, protein, and fat using OEC method. For texture analysis, we use using texture analyzer, Broadfield CT3 texture analyzer, equipped with a cylindrical probe which we analyze hardness, cohesiveness, and chewiness. For sensory evaluation, untrained panel comprising 35 members to assess the accessibility, which we used 9-point hedonic scale. Let's see the result. For proximate composition result, the table shows F2 had the highest moisture, which is around 43%, and highest in protein, about 1.9%. So, using more sweet potato flour helped making dumpling softer and more nutritious. For texture profile analysis, F2 showed the highest value for hardness and chewiness, so the both desirable qualities in dumpling skin. Cohesiveness was also best in formulation 2. These results reflect a good structure, balance, and firmness, which are preferred by consumers acceptable. For the hedonic test, we can see panelists prefer F2 for taste and overall acceptability, while color and aroma were similar across all samples. The natural sweetness and improved mouthfeel from sweet potato made F2 stand out. For the correlation between instrumental chewiness and sensory attributes, there was a clear relationship between instrumental chewiness and sensory perception in formulation 2. F1 had the lowest chewiness and was rated the less acceptability. However, not all mechanical measures perfectly predicted sensory feedback, reinforcing the need for combined the analysis. So, for the conclusion, the F2, which sweet potato flour and tapioca flour 50%, is a proof optimal formulation. It balances texture, nutritional profile, and sensory appeal. This study emphasized the importance of integrating instrumental and sensory method in gluten-free product development. Thank you very much for your attention. For further inquiries, feel free to contact me at rahimawati@ptsn.edu.my. Thank you.